In this video, we are going to be talking about graphing linear equations. Now, you may or may not see this notation as you do your homework, but this is what we call function notation. So we read it as f of x. This does not mean f times x. It is simply giving it a name, so it's naming the function f. You could use any letter there. It could be g of x, p of x, q of x. It's just naming a particular function. And it's telling us that x is the input. So x is the same x as we talked about when we talked about the standard form of a linear equation, but this f of x together is the same thing as y. So f of x and y are equal. They mean the same thing, it's just different notation. We call x the input, or the independent variable, and f of x is the output, or the dependent variable. Now when we go to graph these linear equations, the most common method is using a table. Now what I like about this method is that you can use it for any equation, any function, right? It can be a quadratic, a cubic, a radical function, a rational function. This method works with all types of functions, not just lines. So you may have seen other ways to graph using slope and intercept, but this will always work, no matter if it's a line or not a line. Let's start with this first example. It's graphing the equation y equals negative x plus 3 by plotting points. So you can see this table has some points chosen for us. If it doesn't, you would have to choose those. You can be strategic about it. If you have something that has a fraction, you might pick multiples of the denominator so that you end up with whole numbers. In this case, we don't have a fraction, so we could pick any value we want for x and find the y coordinate to go with it. So I'm going to start with x equals 1. So I'm going to leave y alone because that's what I'm trying to find. Don't lose that negative. Plugging in 1 for x plus 3. So y will equal negative 1 plus 3, or positive 2. So now I have this ordered pair. This is the ordered pair 1, 2. I would start at the origin, I go over 1, up 2. And that's where this point comes from. If I go to the next one, I'm going to let x equal 2. So not losing that negative. And simplifying. So negative 2 plus 3 is a positive 1. That gives me the ordered pair 2, 1. From the origin, I move right 2, up 1. I get the second point. Technically, you only need 2 points to make a line. The third point is generally a check on yourself to make sure you did your math correct. So now I'm going to let x equal negative 1. So I have a negative there, and I'm plugging in a negative 1. What happens when you have a negative and a negative? Well, negative times a negative is a positive. Plus that 3 gives me 4. So 1 plus 3 is 4. And again, I move negative 1 on the x-axis, positive 4 on the y. I get my third point. I connect the dots to make a straight line. Now again, that third point is a check on yourself. Linear equations need to make straight lines. If you don't have a straight line, then you did something wrong, and you need to go back and check your math. Now, let's go ahead and look at these next two examples. Notice here on this example it has that function notation, but I know that f of x is just the same thing as y. So y equals 2x plus 4. I don't have any points given to me, so I have to choose them. So I'm going to make a table. Technically, you could start with x or y, but since this is solved for y, I'm going to choose values of x. So I'm going to choose some positives, some negatives, and 0. 0 is a nice number to work with. So I'm just going to do negative 1, 0, and 1 and see what happens. So for my first coordinate, I'm choosing negative 1 for x, 2, times a negative 1 plus that 4, I get negative 2 plus 4, which is positive 2. So y equals positive 2. And that gives me the ordered pair, negative 1, 2. So from the origin, I go back 1, up 2. If I plug in 0 for x, for my next point, 0 times anything is 0, so y will equal 4, because that's gone. So 0 for x, I go up 4 for y. And then lastly, I chose 1, so I'm going to let x be 1. 2 times a positive 1 plus 4 will give me 2 plus 4, which is 6. So now I plot that point. I go over 1, up 6. Lost my marker here. Oh, sorry about that. I erase it. Over 1, up 6. Oh, put it in the wrong spot. Try one more time. Over 1, up 6. Now, if I did that correctly, it should make a straight line. If it doesn't make a straight line, then I did something wrong, and I need to go back and check my math. So bear with me here. I'm doing this freehand on a computer, but it should look something like that. Now be sure to fill your graph up. Don't do little dinky lines that look like this on your graph. Fill the space. Now you might have chosen different points than I did, and that's okay. These are also solutions here. So if you found any of those points, you still are graphing the same line. There's infinitely many points on a linear, or on a line. Now let's look to this one on the right. This one has a fraction. And as I mentioned before, I don't want to have to graph fractions on this. I want to graph nice whole numbers. Now, fractions are possible solutions, but for graphing purposes by hand, it's just easier to graph whole numbers. So the denominator here is 2. I'm going to pick multiples of 2 to make sure that I end up with nice whole numbers. Multiples meaning 2, 4, 6, 8, so on and so forth. So now in my chart, my table, I'm not gonna pick 1 because that's not a multiple of 2. I could pick negative 2. I can still pick 0. 0 times anything is still 0. I could pick 2. I could pick 4, so on and so forth. I'm just going to start with those 3. So first I'm going to plug in negative 2 for x. So everything else in the equation stays the same. Y, I'm trying to solve for, negative 1/2 multiplied by negative 2 plus 3. A negative times a negative is going to end up positive. And 1/2 times 2, well, that's just a half of 2, which is 1. So 1 plus 3 will give me 4. That's the ordered pair. I plugged in negative 2. I got out 4. On my graph, I go back negative 2, positive 1, 2, 3, 4. Same thing with 0. If I plug in 0 for x, a half times 0 will just be 0. That's gone. Y will end up equaling 3. I don't move left or right. I go up 1, 2, 3. This is also what we call the y-intercept because it crosses the y-axis there. Lastly, I'm going to plug in 2 for x. 1/2 times 2 plus 3. And I have a negative times a positive this time. I will end up with negative 1, right? A half of 2 is 1, plus 3. And negative 1 plus 3 is a positive 2. Now I have the ordered pair, 2 positive 2. And if I did it right, it should be a straight line. Looks like it is. It's going to continue on. Again, those are not the only points you could have found. There are infinitely many on the line.